There we go. Anyway, in hindsight, I didn't realize the diversity of the crowd, and I kind of wish I'd put a couple of slides in of what benthic invertebrates are. So these are the things that kids, young boys, play with when they're playing around in ponds and streams. These are the clams and leeches and worms and various kinds of larvae of insects that live in the bottom of river channels and lake environments. It's very nice background music. Very suitable. Anyway, so benthos, or bugs that live in the bottom of the streams, are a real classic tool, indicator of the quality of the aquatic environment, and as it may or may not support fish and other organisms, so as well as themselves. Monitoring of benthic invertebrates has been in the oil sands region has been carried out in a formal way under the Regional Aquatics Monitoring Program now for about 15, 16 years. I've been part of the consulting group that's been implementing that program for several years now. So I've got an opportunity to tell you kind of the evolution of the program and give you some high-level results of what we've seen over the last 15 years. The program started in 1997 under what was called the Regional Aquatics Monitoring Program. That RAMP was kind of a license requirement of the companies that are operating to carry out a regional monitoring program. Initially, the focus of the program in 1997, benthic invertebrates were monitored in the main stem of the Athabasca River. And as the photograph shows you, there's lots of sand in the river. That sand is a very crushing environment when it's moving downstream. Not a lot of stuff actually lives in that sand. And in 1998, there was a bit of a decision made to kind of switch where sampling was carried out. Because of the objective of RAMP was to detect the effects of land cover change, oil sands operations outside the footprint, but to detect the effect of those operations on the aquatic environment. Most of the changes on the landscape were occurring up in the tributaries. So because it's the tributary water quality that's going to change first, not the main stem, the focus of RAMP moved into the tributaries in 1998. Lakes were brought into the program in year 2000, and the delta, channels of the delta were brought in 2002. So the delta is important because it's actually part of the main stem, and it's an area of high biodiversity. So the delta was brought in a little bit later on to reflect the interests of stakeholders in that location. The bottom of the slide talks about JOSM in 2011. Basically, so now what was RAMP is now being executed under JOSM and AEMERA. I can kind of see that slide, but anyway, this schematic illustrates the general study design as it applies to the tributaries. And I'm going to have a few bullet points to talk about. The points I make also apply to the lakes and to the delta channels that are included in the program. Monitoring is focused on the downstream, focused on areas where we anticipate seeing the effects of oil sands operation on benthic invertebrates. In the tributaries, that means down at the confluence, down near the tributaries confluence with the main stem. We try and get 3 years. We've been trying to get 3 years of baseline data for tributary channels, for lakes as well. But it hasn't always been possible given that this program started in 1997, 1998 when oil sands operations had already commenced. We also try and get data from upstream control locations up and away from oil sands operations. One of the challenges is these upstream controls tend to be some distance away, and just through natural river continuum processes, these upstream controls are never exact matches for the downstream test reach. We always have replication. We go to and sample replicate locations within channel reaches, within lakes, within the delta channels, and revisit those locations every year. Sampling is always in September, which is the time of year that benthic ecologists tend to do this kind of thing. And with an ideal study design, we have a variety of statistical comparisons that we can make, including comparing upstream to downstream time trends, comparing from before oil sands operations to after, and then really in some of the in some of the tributaries, we have the ideal scenario, which is we have the ability to compare before-after control impact, which is any statisticians in the crowd, that's the ideal design. We have a number of reference locations scattered in and around the oil sands region, which allows us to develop reference condition approach models or regional models that allow us to predict what the composition of the benthic community should be for downstream reaches. So there's a variety of tools that we can use, statistical tools that we can use, and ecological interpretation tools that we can use to determine if the variations that we're seeing from time to time have any ecological relevance. The methodologies that were brought into this program in 1997-98 are all similar to or derived from or better than those procedures that were developed for environmental effects monitoring for the pulp and paper and metal mining sectors. So everything here that I'm going to describe and is described in the various reports that we have are all top-notch. I've got a couple of air photos showing where the sampling is occurring. This is showing the Athabasca River Delta. The river braids into four main channels: Embera, Fletcher's, Goose Island, and Big Point. We collect benthos here every September using equine grabs. The benthos are collected from about a meter and a half of water, which is about the most, that's where we get the most diverse benthic communities that's easily sampled every year, and the most likely to show the effects of oil sands operations. We sample under this program now. Initially there was only one lake. Shipyard Lake was brought in year 2000. We now have 9 lakes in the program as of 2014. There were 6 as of 2013. Lakes, again, are sampled in about a meter and a half of water, which is about the most diverse habitat, or where we get the most benthic diversity, and we can routinely sample year after year. Again, we collect samples from replicate locations and go back to those same spots every year. The biggest part of the program is the tributary component of the benthic component. Subcomponent, I suppose. And this just shows basically the study area north of Fort McMurray, shown under the highway sign 63. You can see the areas of land cover change indicated in gray. And a variety of tributaries being sampled in this region, indicated, if you can actually see it, there's orange blobs, or actually larval stoneflies. This is a screen grab off of the RAMP website, actually. Anyway, so this is the bulk of the sampling program, and now more recently, SAGD operations south of Fort McMurray have caused the program to expand in that area. This graph shows the trend over time and the sampling intensity of the program. So basically, in 1997, we had one location. We had the Athabasca River. In 1998, we had 3 locations: Lower Muskeg, Lower Mackay, Lower Steep Bank rivers. And as the projects have come online, oil sands operations projects have come online, the geographic extent of the benthic sampling program has also expanded. In 2014, we went to something like 50 watercourses, water bodies in 2014, and collected almost 500 benthic samples in that process. Hundreds and hundreds of hours of sampling goes into that, lots of helicopter rides to remote locations. A very intensive program. I'm going to walk through the results for 4 areas that I think are key for me anyway. I'm going to show what's happening in the Delta, what's happening in the Muskeg River, and what's happening in the Steep Bank River, as well as what's happening in the tar. So the tar is a bit of a negative control for us. We do see effects on benthic communities in the Tar River. We're not seeing much in the way of effects in the Delta or the other 2 locations, but I'll walk you through how we deal with the data. And there's all kinds of other data available in the various reports that have been published and are available on the RAMP website currently. So these are the data for the Delta. All 4 channels are shown kind of lumped together on the same graphs, but when we get the data back from our taxonomists, we end up with counts of bugs per sample, and those counts of bugs are tough to deal with. It's a very multivariate data set. We crush the data down into, here showing 4 basic indices of composition, but we also do carry out some multivariate procedures that I'm not going to talk about today, but are also available in the various reports that we published. So we can look at total abundance, top left. We look at number of taxa, top right. We look at measures of diversity here, including equitability, bottom right. We also look at percent of the fauna as EPT, or Ephemeroptera, Plecoptera, Trichoptera, or if you like, mayflies, stoneflies, and caddisflies. Those are the 3 main groups: big, large larvae of large insects that tend to be the most sensitive, and they tend to be cleaned out of a system before other organisms. They tend to be the most sensitive to various insults. So we'd like to track those. In addition to looking at things like, there's a lot of statistics that go into this program. We do things like testing, full analyses of variance testing, whether this year is any different than the last year. Is this year any different than the last 5 or 6 years? And is there any time trend in across any of the data? One of the things that, because now we head into 15 years of data, and the last speaker talked about 16 years of data not being a long time trend, long data set. Well, in 15 years of a benthic data, this is actually one of the longest you can find in North America. So we're pretty proud of that, but I know I understand now why 16 years isn't very long. So we're starting to look at the data now in more of a engineering context and looking at normal ranges of variation, and we're looking at different ways of computing normal ranges, including looking at our baseline data, looking at the data just for the channel itself, also using regional reference data to compute an expected normal range of variation for a channel, a lake, or for a tributary. So in the delta, there's not actually much going on in the delta that's causing us much concern. We have all the kinds of benthic organisms we'd expect to see in these channels. Again, the substrate in the channel is very fine sand with silt and clay. It doesn't actually support a lot of benthic diversity. Shown here in yellow is the percentage of the fauna is chironomids. Chironomids are non-biting midges, and we find a fairly good diversity of chironomids in the delta channels, in addition to clams and snails and mayflies and caddisflies, all good things that reflect that the water is actually in good shape. The Tar River is a bit of a different case for us. The Tar River is included. We continue to monitor the Tar River as a negative control to show that the program actually can detect effects. So in the Tar River, we had 2 years of baseline data, didn't have 3, but we had 2, and actually 2 was enough to demonstrate for sure that we were showing effects of land cover alteration. Land covers were being altered in 2004, and there was significant alteration in 2005. And in 2005, the benthic community went from being chironomids, mayflies, caddisflies, clams, and snails to being only tubificid oligochaetes or worms, which was a significant, very significant impact. Things have recovered over time, but in 2013, we have another bit of a glitch in 2013. Steve Gunther talked about the flows of the Tar River being somewhat reduced. I think in the ramp report it says 30% lower discharge in 2013 relative to what would be for a normal condition. We can see here in this pie chart that the benthic community is comprised almost 75% by tubificid worms, which is typically considered to be some measure of impact. The impact in 2013 wasn't as significant as in 2005. We still had clams and snails, but we didn't have any of the mayflies and caddisflies. Anyway, so this Tar River is used as a demonstration site really to show that this monitoring program actually does detect effects when they occur. The Lower Muskeg River data are shown here. The Lower Muskeg River monitoring commenced in 1998 after oil sands operations had actually been in place, so we have no baseline period data. The Muskeg River has been, from a statistical perspective, a bit of a challenge to interpret because we don't have even an upstream control because the upstream habitats are different than the downstream test reach. The downstream test reach is a kind of a gravel, cobble environment. The upstream control reaches are all U-shaped, silty, sandy environments. So the benthic communities associated with sand and silt are totally different than what you'd find in a gravel cobble system. We can use an engineering approach and look at time trends, and what we're seeing in the Lower Muskeg River is that things aren't really trending in any direction. The other thing we can do is look at the fauna of the Lower Muskeg River. This channel here is the lower end of the river is dominated by mayflies, stoneflies, caddisflies, which are all the three main groups that we really want to see in the lower system. We want to see in these gravelly, cobbly systems because they indicate that things are in really good shape. The other thing is, even though in this program we don't have formally any baseline data, there are data from the University of Alberta collected in late 70s, early 80s, and the kinds of sensitive mayflies, stoneflies, caddisflies that were collected back then are still being collected today. So the Lower Muskeg River is showing really no evidence of any undue issues. The Lower Steep Bank River for me is the other kind of hallmark site that I think lots of people have interest in. Like the Muskeg, the Steep Bank has a bit of a hiccup in that we don't really have any true formal baseline data because operations commenced before sampling in 1998. There is an upstream control. It's about 30 kilometers away, and as you could expect, the habitat of the river 30 kilometers upriver is a little bit different than it is downstream. The downstream environment is basically a gravel cobble system, and the upstream environment is a cobble boulder system, and that's enough of a difference to cause the benthic communities to be naturally a little bit different. As you can see in the graph, the light green is the upper stream, and the blue is the downstream test reef. So what we do in the analyses of these data is we look to see if there were any differences in the time trends over the data period. And we're not obviously seeing anything that's causing us any concern. Again, the other thing that we can do is actually simply look at the ecology of the river, and the sensitive mayflies, stoneflies, and caddisflies that we'd want to be there are actually there in good proportion. There's nothing really happening in the lower, there's no indication from the data from the lower steep bank that's caused us any amount of concern. Anyway, that's a kind of a quick run through a very expensive program. It's a program that is based on using procedures that are well recognized across the country. And in fact, the replication and study design that's within this program is probably in excess of what's typically applied for a pulp mill or for a metal mine. Monitoring is detecting variations in composition, as we saw from the Tar River. But for the most part, the benthos of the major tributaries and from the delta and from most of the lakes are in very good condition. This benthic monitoring program, I've got a lot of experience working with benthic invertebrate data sets. This is one of the largest data sets I've ever seen anywhere. I find it really interesting in talking to people when we sit down and talk about this program and design it for the next year. I always say, look, this is going to be a 40, 50-year monitoring program, so just think of it in those terms. This is going to be a very large data set. We've learned a lot of things about normal variations in benthos from this data set because it's one of the longest data sets that we have. Anyway, the data are online for other people to explore, and that's all I have if there's any questions.